Hi, welcome back to Moose and Chemistry. Solutions, colligative properties, lesson 5. If you add 35 grams of NaCl to every 500 grams of water, you will depress the freezing point of water by how many degrees Celsius? Well, to do that, we have to use the formula delta TF equals IKFM. But before we can do this formula, we have a few things we have to work on. First of all, we have to convert grams of sodium into moles of sodium. So first thing we need to know is the molar mass of sodium chloride. So we have 1 sodium, and we're going to make that at 22.99 grams per mole because that's what's on the periodic table. And chlorine is going to be 35.45 grams per mole. So we add this up, that's going to give me 58.44 grams per mole of NaCl. So now we're going to take our formula, 35 grams of NaCl times 1 mole of NaCl divided by 58.44 grams of NaCl. We cancel that out, and that's going to give us 0.60 mole of NaCl. Okay, so let's go ahead and erase some things here and give us a little bit of room. It's important to remember that number, 0.60. All right, now the next thing we're going to have to do, look at this. If you know the formula molality, you know that molality is little m equals moles of solute over mass of solvent, and that has to be in kilograms. But look, our solvent is in 500 grams of water, right? So we have to change 500 grams into kilograms. To do that, we're going to set this up like this. 500 grams to kilograms, right? So first thing you do is you write the number 500. Doesn't have a decimal point, so you give it. So you have to move it over 3 spaces to go from grams to kilograms. And that's going to be 0.500 kilograms. Now we have the two numbers to figure out our little m right here for our molal, right? So we're going to go molal equals 0.60 divided by 0.500. That will give us a molal of 1.2 m. Now the next thing we need to know is our Van Hoff factor, our I factor. So the I factor is the number of ions that's produced. So you have NaCl yields a sodium ion plus a chlorine ion. Now you won't use the Van Hoff factor really for covalent compounds because they don't separate into ions. So the Van Hoff factor for covalent compounds is always going to be 1. But with ionic compounds, which are between metals and nonmetals, you have to count every ion. So this would be 1 plus 1, so the I factor is going to be 2. The last thing we need to know is what is the Kf? Well, the Kf is the freezing constant for a particular solution. And in this case, for water, the freezing constant is negative 1.86 degrees C over m. Now we have everything we need to solve the problem. So we go delta TF equals I KF little m. So delta TF equals 2 times negative 1.86 degrees C over m times 1.2 m. Okay, so now we cancel out our m's, and when we do the math, we get our delta TF to equal negative 4.464 degrees C. So our freezing point depression is going to be pushed down by a negative 4.46 degrees C. So when you're doing the freezing point depression, right, you're just going to go 0 plus negative 4.46 .464 degrees C, which is just going to give you delta T F, the new freezing point of water, will now freeze at negative 4.464 degrees C. So now, they use salt in the lower 48 of the United States, but up here in Alaska, we don't really put salt on the road because it really doesn't depress the freezing point of the snow up here, the ice up here, because it's so cold up here. But down in the lower 48, this salt is actually used quite common on roads. Well, if you like this video, give us a like and consider subscribing so we can grow this channel. You guys be snarly, and we'll see you back here at Moosine Chemistry!